today is to get introduced to VRF and heat pump technologies and their application in enhancing building energy performance and sustainability. So we will have cool topics today by starting by an introduction to VRF system. What is the VRF system application and where we can install, and get introduced to REAM VRF system overview and some advanced features. What is the new features in the VRF market now? And the second part of the training is about the heat pump core principles and how heat pump work, the types of heat pumps and their application, REAM heat pumps system components and what is the expected components either in the air-to-water or the water-to-water heat pumps, case studies for VRF and heat pumps, and some application examples on how the energy saving will be different by using heat pump and VRF solutions. So let's first start with introducing REAM and REAM history. So REAM is a 100-year company founded in 1925 by Richard and Dolan REAM. REAM is a leading global brand in water heating and air conditioning, powered by 12,000 employees and available with products in 88 countries. So I hope this video will show a brief about REAM history.
At REAM, we engineered a full line of air and water products that deliver reliable performance, comfort, and energy savings for residential, multifamily, and commercial applications around the world, providing just the right temperature for virtually any time and any place. Founded in 1925 by the REAM brothers, we've always focused on innovation, quality, and strong partnerships throughout the years, earning a position of global industry leadership. From our early days in producing steel drums, to our shift in 1930 to full-scale manufacturing of water heaters, boilers, and tanks, to broadening our global presence, starting in 1937 with the opening of new facilities in Australia, and expanding across 4 continents today, to developing HVAC solutions in the 1950s to meet the growing demand for central heating and cooling systems. We've engineered solutions that customers need for homes, for businesses, and for life. In 1985, REAM entered the full heater and commercial boiler markets through the acquisition of Raypak. A few years later, we became a wholly owned subsidiary of Paloma Industries of Nagoya, Japan, one of the world's leading producers of gas appliances. And in 2013, REAM added commercial refrigeration equipment by acquiring HTPG. That theme of expansion continues to this day. Across the industry and around the world, we've grown to become the complete air and water solutions provider, with many notable acquisitions over the last several years. In addition to enhancing our manufacturing capabilities, we've also built a robust distribution network across the United States. As our company grows, so does our responsibility to lead the industry in sustainability. In 2019, we launched our A Greater Degree of Good initiative with a set of ambitious goals, and we continue to amplify our impact across the globe to this day. We boldly committed to reducing our greenhouse gas footprint in our products and processes, achieving zero waste to landfill in our global manufacturing, and training the next generation of trade professionals to think sustainably. As we move forward, we will continue to make a difference across the globe by engaging employees, designing innovative products, growing partnerships, and serving our communities. 2025 marks our 100th anniversary. While we're proud of our rich history, our true focus is on the future, to what's next.
So REAM family of brands in the Middle East. REAM have a family of American brands in the air conditioning and water heating solutions in the Middle East as the following. So for REAM, REAM offers a complete air conditioning and water heating product range that starts from mini split to VRF, and for the water heating from point of use to commercial heat pumps. Rood. The name Rood comes from Edwin Rood, the first one to invent the gas water heater. And Rood offers a complete air conditioning and water heating product range, likewise discussed for Rheem. For Richmond, Richmond offers a complete water heating product range, as well as Frederick, which offers a complete air conditioning range for special applications. Our global manufacturing are available in 41 countries, and this is to show some of it. So for air conditioning and water heating, we have our factories in North America, in USA, in Australia for heat pumps, and in UAE, out of 41 factories worldwide. Now, let's start with the introduction to VRF system. So VRV and VRF, so what is the difference? So starting with the basic meaning of VRF, which stands for variable refrigerant flow, while VRV is a variable refrigerant volume. And VRV is a registered trademark, but at the end, both solutions are the same. So focusing on how VRF have many advantages for buildings. So one of the main advantages of using VRF that it will allow different outdoor units to be connected to a network of indoors of different types that can be ducted, ductless, wall-mounted, cassette, FHU, AHU. The wide range of the indoor units offers flexibility in the project's design with different rooms, different requirements. So you have the option to choose from a wide range of indoor units. And as mentioned, you can see in this animation the difference between the full load and the part load, and how the outdoor units in the full load can interact with different cassette units, wall-mounted, different ducted units. We will see almost 3 types of ducted units in the coming slides, and offer a combination and a variety of layout configuration for the building. And as seen in the animation, the conditioned refrigerant moves through copper piping across the building to different indoor units. And when the full load conditions turn to a part load conditions, you can see here how the VRF units will start to decrease its speed and start to modulate its capacity, saving energy for buildings. So initially, what is the VRF system definition? So variable refrigerant flow system are HVAC that vary the flow of refrigerant to all indoor units based on a conditioned demand space, okay, which is specified by wired thermostat or a wired controller. Outdoor units and VRF system consists of outdoor units, and we will see in the coming slides that we can have combination of outdoor units, as well as this outdoor units can be connected to different indoor units, such as wall-mounted, cassette, ceiling and floor, low static pressure ducted unit, high static pressure ducted units, medium static ducted units, which is mostly used for 80% of the projects, AHU and FHU by using an HU kit. Okay, so for example, in one building, you can have a kitchen, so you will need a cassette. You can have a rooms, or you will need the ducted configuration. You might need a fresh air processor unit or a HU for fresh air. So this is part of the different combination of indoor units. So how VRF allow the energy saving? Because it has major components such as the inverter compressor and the DC fans for condenser fans and indoor DC fan, electronic expansion device or pulse width modulation valve, which works together to save energy. So for example, the compressor allows the system to adjust its speed based on the actual cooling demand. So no matter what is the load requirement, the system has the capability of adjusting itself. And since it is a complete DC technology and a complete DC condenser fans and DC indoor motor fans, which work in sync to save energy. electronic expansion valve is one of the most important features in the VRF system because it ensures that the precise distribution of refrigerant to each of the indoor units is happening. All of these three components work in harmony with each other so that the system is adjusting itself in real time to achieve the required cooling load as well as the most energy savings ways. So the questions that might rise, so how it works in details. Okay, so we can see here the outdoor unit that contains the inverter compressor, one or two depending on its capacity, condenser, coil, variable speed condenser fans, different control components such as PCBs, which is refrigerant cooled, temperature sensors, pressure transducer, and a network, for example, of indoor units, ducted, cassette, wall mounted in the same system, okay, that contains evaporators, sensor, and the electronic expansion valve that will control the flow of refrigerant to the indoor units depending on the load requirement, which is monitored by the room wire thermostat. So, for example, the wire thermostat is used to define the set temperature of the zone or the room. Okay, and another one of the famous components for having this configuration of piping is the branch joints. Y joints, U joints, whenever you hear in the market, it's especially designed to distribute refrigerant from the main line to various sections of the system, allowing for efficient distribution of refrigerant as well as efficient cooling. The PCB of the indoor units will compare once the user enters a setting here, it will start to compare the difference between the set temperature and the current temperature of the room and start to modulate the opening of the EEV in each zone based on the temperature difference. Then the outdoor will receive the load requirement from the indoors and delivers the required amount of refrigerant to the system. So once all indoor units EEV opens, suction pressure will increase. Compressor will raise its speed, displace more refrigerant towards the evaporator of each unit. And once discharge pressure here increase, condenser fans will increase its speed. Once cooling demand decrease and all indoor units EEVs start to close, compressor will decrease its speed and as well as its discharge pressure will decrease, the condenser fans will decrease its speed as well. The discussed VRF system control and communication work in a highly responsive real-time control. So this is why VRF are efficient and highly responsive as well. So now we will have a quick look onto refrigerant flow diagrams. I hope both will carry the required knowledge of how the VRF outdoor unit works, as well as we will have the full understanding also of indoor units so that we can connect both together. So here, for example, we are having the refrigerant flow diagram for the outdoor units having one condenser fan or two and one compressor. So looking at the refrigerant flow diagram by using the single DC inverter compressor, we can see other components such as LGS or liquid gas separator, okay, which ensure that the vapor refrigerant coming from the indoor units, okay, so imagine with me this is the outdoor units and here we have copper piping leaving with refrigerant to the indoor units, and here we have the refrigerant coming back in another state as a gaseous state to the four-way valve and then to the LGS or the liquid gas separator. So what is the function of this? It ensures the vapor refrigerant only pass to the compressor because we cannot pass a liquid to the condenser, to the compressor, sorry, because it will damage the compressor. So once the refrigerant returns back from the indoors, it will get introduced to the compressor, and if there is any liquid form, it will get settled at the bottom and will get vaporized over a period of time. During the startup of the outdoor unit, unloading valve SV1, this is a loading valve, will work for 20 seconds to balance refrigerant pressures at both ends, the discharge and the suction of the compressor. And as well as the DC inverter compressor will ramp up to 45 hertz. Okay, it can reach up to 120 hertz of speed, and this is the advantages of the inverter technology, either for compressor or for condenser fans. And once it ramps up its speed for 45 hertz for the first 3 minutes, high temperature and high pressure refrigerant will goes out the compressor and will move to the oil separator, where we will separate the high pressure refrigerant stream from the oil. And oil will be heavier than refrigerant, so that it will deposit at the bottom of the oil separator and then return back to the compressor through a filter and a capillary. Then the hot refrigerant stream will continue passing through the four-way valve, and this four-way valve is used for cooling or heating, for switching the system between either this or this function. So here we are talking about the cooling function. So once it passes through the four-way valve, it will pass through the condenser. The condenser is a high-efficient heat exchanger coil designed to provide 12 degrees of subcooling. And this condenser are cooled by DC inverter fans that was mentioned at the beginning. And it will start to modulate its speed based on the temperature and the pressure of the refrigerant here. Okay, so once there is no more need for more speed and more cooling, it will monitor the discharge temperature and the pressure of the compressor. Okay, and fan gets command, by the way, from the main PCB located in the outdoor unit. Okay, and this main PCB liquid refrigerant here is passing to cool it in the circuit. Why it is passing to cool it? Because refrigerant cooling for such electronics will be better more than the air-cooled PCBs, especially with high ambient conditions that we are having in our area. Okay, so the liquid refrigerant will leave the condenser through a distributor onto one expansion valve, which will remain open. It's only used for heating. In cooling, it's 100% open. And then it can move parallelly through another way with a one-way check valve, which would permit only direction in one flow in one direction. Then the low temperature liquid refrigerant will pass through the heatsink, as we have mentioned, okay, of the refrigerant cooled inverter drives, and as well as it will cool the PCB as discussed previously. Then liquid refrigerant will pass through the storage tank, which can store excess refrigerant in the system, and then it will move for a subcooler. So what is the function of this subcooler? If we recall the basics of HVAC and cooling, subcooling for a refrigerant, which means improving the efficiency of the cooling through a subcooler by 10%. Okay, so once this refrigerant passes through this brazed heat exchanger, on one side you will have the refrigerant coming through the whole cycle. On the other side, you will have a sample of this refrigerant. It will pass through an expansion valve to reduce its temperature, and it will be responsible for cooling the whole stream, moving to the heat exchanger and outside it, leaving the outdoor to the network of the indoors. Okay, and once this part of the refrigerant that is responsible for subcooling is vaporized, it will be regenerated to the unit through SV3 valve to the LGS and back again to the compressor. In the next slide, we will see that we can return this refrigerant in another better technical way to achieve more efficiency and subcooling without any energy loss. Once the vapor refrigerant turns back to the outdoor unit through the gas stop valve, okay, from the indoor units, it will start to pass through the four-way valve and again to the LGS, and the cycle will goes on to have a stable stream of refrigerant. By the way, we have in the VRF system high pressure switches and transducers to monitor the pressures and the safety of the outdoor units and the compressor as well. Now moving to another outdoor refrigerant flow diagram, and here the same cycle is working with the same terminology, but the difference will be here that this one is used for bigger units that can reach up to 36 horsepower. Okay, so we will have two compressors, which is inverter as well. We will have two oil separators, gas separators, one oil separator, one large oil separator, four-way valve, and a bigger condenser with two condenser fans. And once the capacity goes bigger, for sure, components will be big in size and will be two instead of one, for example. And here we can see two branching as well after the condenser, refrigerant cooled PCB, and a subcooler. So the same diagram will move with the same logic and the same terminology for the VRF. So gas refrigerant will pass from the gas separator to the compressors, and once the compressor raises pressure, it will go to the oil separator as a high pressure, high temperature refrigerant stream. Oil will be pushed back as it's heavy, so it will remain here till it moves through the core dryer filter and to remove any moisture, and as well as through oil return capillaries back to the compressor to guarantee the oil return function is working precisely. And the refrigerant will complete its journey through the four-way valve and then to the condenser coil, and then after cooling down as a subcooled refrigerant, it will pass through the expansion valves for heating, which in cooling, as we are discussing, will remain open 100%. Then also through this way of one-way valves, okay, and non-return valves, and it will move through again in a one stream to refrigerant cooled PCB, as we have mentioned, which is cooling better the electronics of the whole system, okay, of the outdoor, and then it will pass through the subcooler. And here we can see the subcooling also in another idea. So we are capturing part of the stream, moving it to electronic expansion valve, use its temperature to improve the subcooling stream going outside the liquid valve to the indoor units. Then we have to wait to return this refrigerant, either to return it to the gas separator like discussed before, or to return it to the compressor, as it will be a saturated vapor and achieve enhanced vapor injection technology, which will increase the capacity of the system and the compressor and the efficiency of the whole cycle. The same the suction valve refrigerant will return back from the network of the indoors, will pass through the four-way valve and back to the gas separators. Service valves are used only during service or startup and commissioning. I hope this flow refrigerant diagram is clear. We have discussed it almost 2 times. It's the same cycle with more details. Now, this is the indoor refrigerant flow diagram. So we have the fan, we have the evaporator coil, we have temperature sensors, we have the electronic expansion, who is the boss of cooling here. Okay, so the control is achieved by continually varying the flow of refrigerant through this electronic expansion valve, and its opening is determined by the microprocessor PCB that receives the information from thermistor sensors located in the each indoor unit. So the indoor units are linked by a control communication wiring to the outdoor units, which responds to the demand from the indoor units by varying the compressor speed to match the total cooling or heating required. Okay. Now the sensors, we will have 4 sensors in each indoor. So the indoor temperature sensor, and the TC1, TC2, here you can see the inlet evaporator temperature sensor and the outlet evaporator temperature sensor. The medium coil evaporator temperature for better measurement of half the coil, and as well as once indoor fan starts, this expansion valve will open, PCB will sense the requirement delta T, and as well as the outdoor PCB will sense the increasing capacity, will ramp up the compressor, and based on delta T, the electronic expansion will be controlled to open more or to close, as well as the controlling the outdoor for the speed of the compressor and the condenser fan. Now moving to the VRF combination ratio. So it's one of the important parameters during the VRF selection, and it is defined as nominal indoor capacity, the sum of nominal indoor capacity over the total nominal outdoor capacity. Okay, so the recommended combination ratio or CR is between 80% to 130. So let's take two examples to understand how we can calculate this. So for the first system, we have 26-ton outdoor unit. We have 4 indoor units, each of 2, 4, and 10 and 6 capacities. And if we sum all of this, it will be 22. And once we divide the 22 by 26, we will receive 85%. Okay. And once VRF system is engineered with a CR less than 100, so we have outdoor is oversized. Okay, which is better to see the result as the second system, which have a 24 capacity, okay, and 24-ton capacity, and 4 indoors, but 3 have 8 tons, and the other fourth one have 6 tons. When we sum all of this, it will be 30 divided by 24, which will give us a 125%, okay? So as well as the 85 is accepted, and as well as in the 85 you can have more availability to connect more units. Some might think why we are having a CR 125%, is it safe as a design? The idea here, gentlemen, is that when we connect more indoor units capacities, more than outdoor capacity, we are relying on the fact that all the indoor units will not operate in full load on the same time. And this terminology is called block load or diversity factor. I hope the introduction of VRF system was clear. I hope it introduced the idea clearly to everyone in the training. So now moving forward with the VRF system applications. So where we can install the VRF system, one of the major advantages of the VRF system is that it can serve different project applications, from residential to commercial applications, such as the villa, the residential compounds, the commercial malls, hotels, schools, universities, and offices. So VRF system is ideal for diversity of application, as we can see. What about the project's retrofit challenges and how VRF can serve solving these challenges? So there are a lot of retrofit projects challenges for any air conditioning system, which is the limited space for new ductwork and equipment due to low ceilings. Ductwork can be destructive and expensive. Overall, energy efficiency needs to be considered for upgrading the aging equipments. New zoning or areas might be required to be added to the system. Okay, so how VRF can be suitable for this retrofit challenges with many advantages. The piping will be compact and can be easily routed through existing risers. The compact indoor units can be easily installed in the existing ceiling with slimmer designs than before. Installation of few outdoor units connected with multiple indoor units allows for best use for installation space. The provision of individual control per indoor unit and VRF central controller per building for central monitoring, as well as the energy efficiency operation of VRF will help improve the building energy consumption and sustainability. And we will see one comparison at the end of this training between using DX solutions and VRF solutions. So now moving forward to the next part, which is REAM VRF overview and special features. So for every brand in the market, you will hear a terminology of mini VRF, okay, and modular VRF. So starting with a mini REAM VRF, side discharge, which is used for the small scale of projects. So we have the indoors from 10 to 14 for a single phase of power. For the three phase of power, we have the range from 16 to 22 kilowatt per unit, which is approximately 3 to 6 tons, this range. So Green Mini VRF can have combination. Okay, now we will see combination of outdoor units for more capacity serving. So up to 3 outdoor units can be combined together to reach a maximum of 66 kilowatt per the system. So once we combine the outdoor system, we start to call it a system 1, for example. Okay, so the 66 is one of the highest capacity in the market for many VRF. Now moving to a modular VRF units, so we can see that the modular range starts to go bigger in capacity, which is by single fan, single compressor can be in the range of 8 to 12 horsepower. For dual fan, single compressor, it will be 14 to 22 till the higher capacity version of dual fan, dual compressor from 24 to 36. Okay, and once we will start to have combination of this outdoor, we can have a system range from 32 to 70 horsepower, and a combination of 3 units, 74 to 108 horsepower. Then the largest capacity in the market, which is having 4 outdoor units and having a range of 110 to 144 horsepower per system of VRF. Now, speaking on another terminology, what is the main components of the VRF? So we have the outdoor units, indoor units, and controllers. Okay, so outdoor units, as mentioned, you can have a combination of 4 outdoor units for REAM with a single capacity of 36 horsepower. For the indoors, you can connect different indoor units depending on the project requirements. So, for example, they can require 5 units of wall-mounted, 6 units of cassettes, for example, for a single kitchen or multiple kitchens available, a ceiling and floor, slim ducted units for low static units and slimmer ceiling required, medium static, which is 80% of the projects in the kingdom, and high static ducted or fresh air processor units for introducing fresh air to the building, or the AHU and the FHU that can be available through an HU kit between the HU and the VRF system. And as well as the last part is the controller, which is the wired thermostat found in each zone or in each office, if it is an office building, or a central controller that can combine up to 256 indoor units with BMS compatibility with different BMS like Modbus and BACnet. Now, for each indoor units to be suitable for different projects requirements, there is an indoor offering. Okay, so for a compact cassette, it can goes up from 2.8 to 5.6 per unit. For cassette, it can goes up from 2.8 to 14 kilowatt. For a slim ducted, it can goes up from 1.5 to 7.1. For medium static, it can goes up from 4.5 to 16 kilowatt. And for ceiling and the floor, can goes up from 4.5 to 15 kilowatt. For wall mounted, it can goes up from 2.2 to 11 kilowatt. For the high static version, it can goes up from 22 to 28 kilowatt. For the fresh air processing, it can goes up from 22 to 28 kilowatt. And these units offer the flexibility for the project owners for fresh air processing unit without the need to install FHU for fresh air processing. Also, system can be connected to AHU kit that starts from 3 horsepower to 38 horsepower, and we will see it in the coming slides. Now, when you are speaking about VRF system, you have main features in each product, and the old mindset in the market that VRF, once it's operate and once there is a failure in one compressor or one condenser fans or even one indoor, it can shut down the system. Guys, this is the old fashioned systems. Now with the auto backup technology, we have a backup for each thing, even the indoor, so that the VRF system will not stop operating at all. So moving to part of the main features, we have 4 combined outdoor units that can offer up to 144 horsepower with each module of 36 horsepower. Largest difference between indoor and outdoor, the carriage up to 130. Hitachi scroll inverter compressors is used, and Panasonic condenser fans. And by the way, Hitachi was the first company to invent the inverter scroll compressors in the early 80s. Plate heat exchanger for subcooling that was defined in the refrigerant cycle, if you remember. Compressor enhanced vapor injection that cools the compressor and lowers the compression discharge temperature and improves cooling efficiency as well as compressor capacity. Floating refrigerant temperature, which means that we adjust the temperature of the refrigerant to adjust the off coil, and it is adjusted from the main PCB controller, as well as it controls the compressor speed to improve cooling efficiency, energy consumption, and the seasonal energy efficiency. Refrigerant cool PCB for better operation in hot climates, as well as automatic refrigerant recycling. Automatic refrigerant charging, and you will see it in the coming slides for easy startup and commissioning. Wide operating range that can reach up to 55, and auto reverse dust function. Auto restart function after any power failure, and 360 piping technique. Turbo mode as a standard feature. Outdoor changeable static pressure, and as well as auto backup technology for compressor. Fan motor outdoor module. You will see how this technology solves the old mindset fashion about the VRF. So now, in speaking of the piping capabilities for the VRF system, so for the total piping, our VRF can goes up to 1,000 of meters. This means the total piping between outdoor and indoors for a single system, it will be 1,000 meters. The longest length in actual between outdoor and indoors can goes up to 200 meters. And the longest length after the first Y branch, or after the first branch, or the branch joint that we have discussed earlier in the training, it will be 90 meters to the last indoor. Speaking of the largest height difference, that can start from 110 and goes up to 130 meters. And now, in terms of the height between the indoors, it can goes up to 30 meters. So here you can see this is the plate heat exchanger for subcooling. On one part, we will have the refrigerant stream coming in and going out after being subcooled to the refrigerant cycle to the indoor units. And here we can see that we have take part of this sample, move it through electronic expansion, and then start to cool down the whole stream. And this improves the refrigerant subcooling and ensure that the whole system overall efficiency is improved by 10%. While the other EVI technology, which we were mentioning that we will use this vapor or this refrigerant, once it returns to vapor, we will return it to the compressor, not to the liquid gas separator. So by this, we are achieving better cooling efficiency as well as better compressor capacity. And let me show one animation how this is work. So this is the scroll compressor working. And here you can see the saturated vapor stream coming from the subcooler. So what you have taken from the system, you have returned it back. So you have done a subcooling without any energy efficiency loss. Now moving to the PCB, refrigerant cooled PCB, special design allow the refrigerant to cool the PCB section and prevent it from overheating. Okay, this is one diagram for the outdoor unit, and at the back of the panel you can see here a heat exchanger with liquid piping moving so that liquid refrigerant will cool the whole panel and PCB section, preventing it from overheating compared to air cooling PCB, to offer stable operation for the VRF units as well as a long PCB time, long lifetime for the PCB. On the other side, we have something called 360 degrees piping connection mode. So for constraints inside systems, in terms of space, in terms of installation space, the units have 4 routing slots like this on the 4 sides, so that the contractor or the installer is allowed to connect the liquid and the gas connection to the outdoor from any side. He is not dedicated to connect it from the front, that he can connect it from the 4 sides. Now moving to another new feature for the market, which is the automatic refrigerant charging. So half of the projects of the VRF issues are in the piping in the installations, and the other half are startup and commissioning and the charging the VRF system. So this feature acts like a verification tool for the installers. It depends on pressure sensors built in the outdoor unit that monitors the status of the refrigerant and ensure that the required amount only is charged, which enables for easier installation and maintenance by selecting one function from the VRF PCB and start monitoring the system feedback during the charging, which can be undercharged, so it will show you F1, or overcharged, so it will show you F3, or well charged and it will show you F2. So this is one of the cutting edge technologies that is introduced now, and as well as auto reverse dust function, which enable the outdoor fan to rotate automatically in the opposite direction, clearing dust from the heat exchanger, improving the VRF system proactive maintenance, as well as after doing this function, it will return back to its main setting and start operating. In case of space constraints, we can see here, we can install a duct on the outdoor units and remove the fan grill. And this is as a standard in the VRF, it's not optional. And it can accept a duct of 80 to 125 Pascal, depending on the unit capacity. And it can be easily configured for the outdoor unit without the need to code another options. It's a standard in REAM VRF. So now for the auto backup technology, this technology allows the VRF system to complete operating when any outdoor unit or condenser fan or indoor unit fails, or even a compressor fails. So in case one module breaks down, the rest of the modules in the same refrigerant system will operate, and even if this unit is a master unit, the system will assign the first slave outdoor to be automatically the master. In another case where compressor will fail, the other compressor in the same outdoor will ensure operating normally and ramp up the speed to compensate for the other compressor. If one condenser fan breaks down, the other fan will ensure that the outdoor unit operates normally, ramp up the speed to compensate for the other fan stoppage. The indoor, so you can see here how the connection of the communication wiring that we was mentioning earlier in this training, from the outdoor, and between all the outdoors you have 2 communication wiring to all the indoors till the last indoor in the system. So REAM VRF use a robust communication RS485 daisy chain communication technology to prevent the failure of a single indoor unit from bringing down the entire system down. So in a correctly wired system, the communication, as you already can see, continuing to function for the healthy units, and for the faulty units, it will only stop responding to commands. But for example, if this unit stops, this unit will receive signals and continue operating, unlike other brands. In a correctly wired daisy chain, the communication line will pass sequentially from one unit to the next, and the wiring is designed so that a failure in one unit electronics does not affect the communication path for the indoor down the line. Okay, up to 3 indoor units, gentlemen, in the whole system can trip without affecting the system operation and performance, while more than 3 units, the logic inside the VRF system and the outdoor unit will stop operating, because it will suspect that this is a general power failure. To protect all the system, it might do this. But for example, if you would like to do preventive maintenance in one indoor, you can. If you have one stopped indoor or up to 3, you can still operating your VRF system without distributing the cooling for any of the VRF system in the building. Now, I hope this video will summarize all the mentioned points for the SAVAR VRF.
Four units combine total capacity up to 144. Auto snow blow function, and auto dust removal. Intelligent defrosting. Gold and black fins both are optional. Compared to previous systems, it can save more space. It's more convenient to install pipe. Elevation difference up to 130 meters. Easy panel removal. Auto refrigerant charging and recycle. The indoor units can automatically distribute IDU address. Support auto conditioning. High static pressure grill. It has silent mode. Low pressure sensor. The temperature fluctuates within plus or minus 0.5 degrees Celsius. Automatically adapts to the environment. Support gateway integration. BMS solution. Centralized controller. Weekly timing. Bar alarm linkage function. And can achieve electricity allocation and automatic deduction for billing. The indoor units support multiple control methods. Technology leads intelligent life.
So now, moving to the VRF controllers. So REAM offers a wide range of VRF controllers. We will start with the standard, which is the standard for all ducted units with 8 key touch inputs, as well as error codes to be displayed on the left, and another version that have weekly timer and history errors. The second is the touch screen centralized controller that can control up to 256 indoor units, providing a wider, complete follow-up and monitor and control for the whole building, and as well as it can switch off the system in case of any fire alarms for the building, as well as the remote control for the standard high wall, okay, and cassette units to be able to achieve fan speed settings, swing settings, and sleep settings. Now, moving to one also of the most advanced features for VRF to be integrated with HU. We used to hear that HU can be connected only with a chilled system, but now through an HU kit, the VRF can be connected and integrated with FHU or HU as an efficient solution to achieve better indoor quality and ventilation requirements. So the HU kit will enable the system to connect and be incorporated as well with the VRF system, and as well as it can act like a one-to-one system with the VRF outdoor. So in order to understand it completely, what is the HU kit components? It have the EEV valves, the control PCB for the EEV valves, as well as main interface PCB between outdoor unit and the HU. And it will have 3 connected sensors to be installed, 2 on the gas and liquid temperatures across the evaporator coil of the HU, and another will be a room sensor depending on the type of the HU. As well as AHU kit allows the system to control the operation of the VRF system, and as well as control the operation of cooling and heating modes, and the speed of the AHU fans, and as well as the heater electrical control if required or installed. Now, moving to how the system can be connected. So here we can see the outdoor unit and the HU or FHU. AHU kit in the middle as a synchronizing component between both, and as well as we can use the REAM or the wire controller, or we can use the PLC DDC controller, okay? And this is the liquid and gas vapor lines going to here, and here we have the expansion electronic valves that we have mentioned before because we cannot locate it inside the AHU. And our VRF, REAM VRF integration with HU had many advantages that are not available from others. So VRF can be integrated with HU and other indoor units, and thanks to the wide range of REAM VRF outdoor capacities that will support this combination, as well as once HU had an issue with the fan belt damage, the VRF outdoor unit can stop in 50 seconds. And if the reverse happened and the VRF outdoor unit encounters any fault, the system is capable to stop the FHU or HU with the DDC and PC control option. Okay. Combination of the VRF with HU and the other indoor units, the high capacity will support this, and this is very special for REAM, and as well as combining one outdoor unit only with the FHU also is part of the space saving for such a solution. I hope the VRF board was clear, was informative, shows us from the start what is VRF till what the options and features that start to be available in the market. Now we have come to the Q&A part. Please let me know if you have any questions. Please write it in the chat, or we can start moving further to the next part, which is the heat pumps. Case configuration. No, there is no VFD is required with the HU. Can operate with the fan, and as well as the HU kit is ready to deal with a fixed speed motor or an HU with a VFD motor. Both can be achieved. The reliability to continue with power generators, I cannot get. We prefer, okay, it can operate with the power generators, but we should ensure that the main incoming lines and neutral are in the stable range for the operation of the outdoor units, so that it will not cause any damage to the PCBs. Yes, there is recommendations for the outdoor unit and the indoor units. So the regular preventive maintenance for the condenser coils, as well as the checking. If you have noticed in the video, there is a complete software that we offer to the user so that he can connect through the laptop and have a complete log of the parameters. For example, if you have seen any transducers or any sensors show wrong readings, you might need to intercept with a clearer preventive maintenance. So for the outdoor, the regular cleaning of coils, as well as the regular checking for electrical terminals, the regular checking for the pressures and the transducers, and as well as the temperatures of the system of the outdoor unit, as well as for the indoor units, the regular cleaning of the filters, as well as regular checking of the electronics tightness, as well as function, and the electronic expansion operation, because after some certain years of operation, might be if the electronic expansion get faulty, or it might affect the whole system or the whole room cooling if it has any malfunction. Yes, for the system services after sales and commissioning, for sure there is a warranty services, as well as there is a support from our team and the follow-up for testing and commissioning, and as well as we have mentioned, we can provide you the software that can keep you monitoring the system from your office, and your technician can be easily monitoring the system in case of any thing. And for sure, we have a wide range of warranties and service support for our customers. Yes, VRF can be used for the industrial buildings. You can have maximum tons. You can have up to 144 horsepower. I think it's almost 120 tons of refrigeration. And you can have more than one system. So what is system of VRF? The VRF system can be for outdoor units, and then according to the project design, can accept the maximum indoor units can. And if your building needs another system, we can have another VRF system installed in the same building. For the maximum length of the copper piping, it can goes up to 200 meter, and the total piping of 1,000 meter. For delta T will depend mainly on the indoor temperature and the indoor temperature reading by the wire thermostat, which is sent to the door PCB. And this delta T might be varying because you might turn off the whole room for the whole day. So it depends on which time you turn and the internal temperature of the room. Yes, the red line was for the heat. I only discussed the cooling because the system will do either cooling or heating. So heating will be reversed for the whole cycle that we were mentioning. It will be reversed so that the system will continue operating in a heating mode in a completely reversed way than the two I was discussing. No, electronic expansion valve will not be at the inlet side of the compressor. Electronic expansion valve will be on the inlet of each indoor unit installed in the system. Okay, so the outdoor that I was discussing, and there is copper piping moving to, for example, rooms inside the building. So for each room, there is an indoor unit, and for each indoor unit, there is electronic expansion valve that will vary the volume or the flow of refrigerant to it depending on its need. I hope it's clear. For VRF installed in reliable, yes, for sure it will save energy more than any other solution, and you can track. Yes, you can, for example, look at the thermostats. We have other solutions where you can, for example, use even a DX solution and lock the whole system from your mobile and control it from yours only. We can show it in another late training. Yes, we will have an oil trap, and it is designed according to the copper piping diameter as well. Lifespan of a VRF system, if it was monitored fine and if it has its regular preventive maintenance, it can go up to 15 years. It is not at the evaporator of it's at the evaporator inlet near Salim, because it will control the amount of refrigerant going to the indoor based on the temperature required or the cooling required for, and it will close once this need has gone or the temperature is satisfied inside the room. Electrical power feeding will be three-phase and neutral. Yes, the slave unit can continually, as I have mentioned, the backup setting will be available for 24 to 48 time. And even if you would like to renew this setting, so we train your technician to just enter a dip switch setting, which is very simple, and then he restore the power, and the system will continue for another 48 time. For example, if you mean by maintenance here preventive maintenance, yes, even if it happened like a failure and there is no one there, it will automatically turn the first slave unit to be the master and continue running. It depends upon the capacity of the system. So, for example, if the HU go bigger, you can see up to 4 kits of the HU kits in the middle. So, why you will have 4 kits? You will need more refrigerant, so you will need more electronic expansion valves. The fire alarm control. In this case, we prefer to use a central controller where it will have the upper hand to stop the outdoor and the indoor systems of the VRF responding to the fire alarm. In case of fire activation system, immediately the VRF central controller will allow the system to shut down and will not allow anybody inside any of the floors to switch the thermostats or something, because the upper hand control here will be for the central controller, which can as well be integrated with a fire input so that it will act immediately and protect the building. Yes, I have answered this. It is just a representation, engineer. Okay, so I hope we can continue. So heat pump. So heat pump uses vapor compression cycle to transfer low-grade heat energy into hot water. Almost the energy source will be minimal, which will be used to drive the fans and the compressors in each of the solutions, making heat pumps extremely efficient. So heat pumps types are hybrid heat pump, air-to-water heat pump, or air-sourced heat pump, as well as water-to-water heat pump or water-sourced heat pumps. Now, identifying each and every one types. So as you already can see here, we have the hybrid heat pump. Okay, so why we call it a hybrid? Because at some edge or part of it, it's a central electrical water heater. But our team has innovated in another way to make it a heat pump be installed and make it a hybrid solution. So this is from where come the hybrid solution. So how it works? It uses the vapor compression cycle along with two heating elements that are working in a non-simultaneously way. What is non-simultaneously here means that if I operate one heater, the other will not work, to allow for energy saving and allow for the maximum saving in operation by heat pumps. So how it works? Ambient air is drawn through the inlet fan, okay, or through the fan. There is an opening here and the fan is installed here. So once fan operated will start to allow air to come in, passing through a filter and then the evaporator coil. So once it is drawn, the liquid refrigerant inside the evaporator coil, okay, and back to the basics, the refrigerant in the evaporator coil will be low pressure, low temperature, liquid form. So air will be hotter than the refrigerant and will release the heat to the refrigerant. So air will move cooler and leaving the heat pump. Here refrigerant receive a heat, so it will evaporate and will goes to the compressor and then moves outside the compressor as a high pressure, high temperature refrigerant vapor. Where is the condenser? The condenser is wrapped as a complete condenser piping around the inlet water tank, as you already can see. Once it is discharged to the condenser, it will release the heat to the water. And once it releases the heat to the water, water will become hot. Okay. And please be informed that the condenser coil and the internal water tank inside this water heater is completely separated. Okay. And there is no any risk or any function that might happen that might cause refrigerant leak to water. Both are separated, as I mentioned. Once refrigerant here release the heat to the water, through basics also, refrigerant will condensate because it has released the heat energy to the water. Now it will condensate to a liquid refrigerant. Then it will pass through a metering device, so that this metering device or this expansion valve will reduce its temperature and pressure so that it will be introduced again to the evaporator in the low pressure, low temperature liquid form, ready for another cycle. So to guarantee, because the heat pump concept is new, to guarantee that each and everyone is understanding it more, so here's a more technical representation. So we have here the evaporator and the DC fan, compressor, condenser, throttling device, or metering device. So as ambient here is drawn through the inlet fan, the heat is absorbed by liquid refrigerant in the evaporators and air become cooler and leaves the heat pump, while the refrigerant R134A will be low pressure and low temperature vapor, will move to the compressor to raise its temperature and pressure, discharge it to the condenser, and as you already see, the black one is the heating tank, and on it you can find the condenser wrapped down so that it will heat water up to 65 degrees, and in each cycle we can have a temperature increase by 5 to 7 degrees for a water which is produced at 20. Once this heat energy is released from the refrigerant in the condenser to the water in the tank, refrigerant will condensate, as we have mentioned, to high temperature, high pressure liquid form, and will pass through a metering or a throttling valve that will reduce its temperature and its pressure, and it becomes a low temperature, low pressure liquid, almost liquid form, for another ready for another cycle, and the cycles will goes on. So how looks like from inside? So as we have mentioned, this is the air inlet, and by the way, the product name is Protera Hybrid Heat Pump, which is available in 50 and 80 gallons. And our R&D are developing more capacities now. So air inlet here, air filter, evaporator coil, metering device, condenser, inverter, DC fan, as well as rotary type compressor, water outlet, water inlet with a shut-off valve, and as well as the water outlet and the water inlet can be at the top for easy old system replacements, and it's available. Water tank, condenser coil wrapped around it, and two heating elements, each of 4.5 kilowatt, operating in a non-simultaneously way, as we have mentioned. Drain valve, and an intelligent leak detecting sensor. So once it detects the leak, either from the fittings or the tank, it will shut down the valve and show the user on the UI controller an error. Okay, and by the way, you can dry it and reinstall it again, because we are not considering it as a spare part. So once it is dried, you can install it, reset your system, and let it operate again. So in the UI controller, we have also an advanced feature to operate the system with Ream Econet free software, so that you can add all the hybrid heat pumps in your building in one display and operate it from a single tablet or mobile. So Econet is a Ream-based application that support controlling hybrid heat pumps through Wi-Fi control. There are two parts of Econet, which is the intelligence, the smart features of the water heater, and the connectivity on how this information will be relayed. So in terms of leak sensing and health alerts to be shared to the customer with troubleshooting to do it, and as well as it provides different commands and control on the temperature setting, the scheduling of different operation modes across the day, as well as the user can track the energy usage per day, per hour, almost per year, and start also to monitor the health alerts and the error alerts, as well as the hybrid heat pump can operate in 4 different modes, and the user can program the different mode per hour, per day, depending on his need. So for example, the mode that can operate high demand mode, and high demand mode, you will have the hybrid heat pump operating, and this means that you need a high hot water demand. So one upper or lower water heater only will operate, so that it will allow the user to have more hot water demand. The second is the heat pump mode only. So the heat pump mode only will operate without any electrical elements, so that it will provide the hot water production in the most efficient way. The third one will be vacation, so that the user or the building, in case it's closed. And the fourth one is the energy efficient mode. So by selecting this mode, you allow the heat pump to produce hot water in the most efficient way and trigger in a very little manner the electrical water heaters, like little triggering, so that it will achieve most energy efficiency as well as most higher hot water demand. comparing hyperheat pumps with electrical water heaters as well as solar water heaters. So running cost in terms of hyperheat pump will be 75 lower compared to electrical, 50 compared to solar. And in terms of running cost for electrical water heater, it will be higher. And for solar water heater, overall high operation cost compared to heat pump. Energy efficiency, the hyperheat pump COP can rise up to 4.07. Okay, and comparing this to the COP for electrical, it will be 0.93. For the solar, it's almost 1.9. And in terms of smart controls and temperature setting, you can adjust and control the device through your Wi-Fi mobile application, and you can control it from anywhere. And for the electrical water heater, you have manual basic control, while for the solar water heater, you have a limited temperature control as the primary source is the solar. Lifetime can goes up to 10 years for hyperheat pump with minimal maintenance required, 7 years for the electrical water heater, and 5 for the solar. And if the ease of maintenance and the preventive maintenance is required, you can expect your hyperheat pump to goes up for 15 years. Recovery, it will be faster recovery compared to slower recovery and slowest by the solar. In terms of easiest of maintenance, it have a smart leak detection as well as smart diagnostics for the user. But what is the maintenance needed? To clean a filter like your mini split filter in home, and only to check if there is any error. For electrical water heater, it's easy maintenance as well. For the solar, the main issue is the difficult maintenance and the frequent maintenance required for solar panels cleaning, as well as frequent refilling of heating medium. In terms of sustainability, for hyperheat pumps, it's high due to high efficiency and higher COP, smart water leakage detection and water control, low due to high electrical consumption. We can say it's moderate for the solar due to overheating at summer, as well as it is requiring an electrical backup during winter because of the weak solar irradiation in winter. So the main dependency will be on the electrical backup element. In terms of product cost, the hyperheat pump will be the same to the solar water heater, while the electrical will be the cheapest solution here. In terms of installation and the operation cost, hyperheat pump will be less and almost same in the installation cost of the electrical. It's water connections just. But for the solar, it will be higher in terms of installation and operation cost, while for the operation cost, as we have mentioned, hyperheat pump will be the least. In terms of maintenance cost, there is no maintenance required for the hyperheat pump, almost. Very few maintenance activity compared to electrical water heater, while for solar, we have mentioned you need follow-up and frequent preventive maintenance for the panels cleaning out of dust in order not to lose the system efficiency. For the plant room and the size required, so if the unit is not ducted, it will require a 700 feet cube room with doors louvered up and down or full louvered for better air exchange. But the unit is already ready with connections that can be duct in and duct out. And by the way, this operation of ducting, it can operate at any room size, and as well as the outlet with cooler air, so it can be used to cool down any other rooms or areas, as well as for the inlet, it will bring the hottest available air as well from the ambient air. For electrical, it's 0.4 square meter, while for solar, it is 2.2 square meter. Now, moving to a video that might refresh our understanding of the heat pump principle and make our brains ready now for the next principle, which is the commercial heat pump principle. So I hope this video will clear the thoughts.
This animation illustrates how a heat pump operates. Generally speaking, a heat pump transfers heat from the air in the room to the water in the tank with the aid of a substance called a refrigerant. As it cycles through the system, the refrigerant undergoes variations in temperature and pressure, as well as alternating between liquid and vaporous states. Let's examine the 4 stages in one complete cycle. In the beginning of a cycle, the refrigerant is in a cold, low-pressure, liquid gaseous state, flowing through tubes that are exposed to room air. It is colder than the room air, so the heat in the air moves to the refrigerant. This is because heat always wants to move from warmer things to cooler things. To facilitate the heat transfer, the tubes are connected to an evaporator, a heat exchanger much like a car radiator, with many fins designed to increase the absorption of heat from the warm air into the cold refrigerant. A fan amplifies the absorption by increasing the flow of room air over the evaporator. The heat added to the refrigerant causes its temperature to rise and the fluid to become a warm, low-pressure vapor. As the refrigerant changes from a liquid to gas, large amounts of energy transfer take place. Once it's passed through the evaporator, the refrigerant is a warm gas, the cold liquid having been warmed and vaporized by the room air. The refrigerant is still not hot enough to heat water, however, so that's where the compressor comes in. The compressor raises the pressure of the gas, which also raises its temperature. Once it's hot enough, the heat will flow from the refrigerant to the water. The compressor next forces the now high-temperature, high-pressure gas further along the cycle into another heat exchanger called the condenser. The condenser is in contact with the water, and the hot gas now gives up its heat to the colder water. As heat leaves the gas refrigerant, it cools off below its condensation point and changes from a gaseous state to a high-pressure liquid state. The change from gas to liquid facilitates the large transfer of heat energy to the water. Finally, the now cooler, high-pressure liquid refrigerant passes through an expansion valve. As the refrigerant passes through the valve, its pressure and temperature are greatly reduced. Now cold and in a vaporous state, the refrigerant is once again ready to absorb heat from the room air and repeat the cycle.
So I hope this video clears the idea of heat pumps. So now we will introduce 2 types of heat pumps, the air-to-water and the water-to-water. So the air-to-water heat pump absorbs the heat from the ambient air and transfer it into the hot water that needs to be heated. So how it works, ambient air is passing through evaporator, and refrigerant inside the evaporator will turn into vapor once it's absorbed the heat from the ambient air. Okay, and the air will now move as a colder air outlet through the fans, okay, through the evaporator fans, while the refrigerant will pass to the scroll compressor, which will raise its temperature and pressure and discharge it into a heat exchanger condenser, so that it's a shell and tube heat exchanger where refrigerant is inside the tubes while the water is in the shell. Okay, and water is used or is passed to the heat pump by from the calorifier through a complete circulating pump, and once it absorbs the heat, refrigerant will condensate. Then it will be in a liquid form, but still it's high in pressure and temperature. Then it will pass through the expansion device to reduce both pressures and temperature and be ready for the next cycle. By the way, it's available starting from 24 kilowatt up to 220 kilowatt per unit. So this is a complete refrigerant cycle for better understanding, showing the main components such as the evaporator, which is 5,000 salts per hour, coupled US made compressor, shell and tube condenser, and TXV. So basically, as shown in the heat pump representation, ambient air is drawn through fans, and once it passes through the evaporator coil, liquid refrigerant will absorb the heat, will turn to vapor state, and cool air will leave the heat pump. The vapor will pass to the compressor, and by the way, the refrigerant is R134A. So as a low temperature, low pressure vapor will be push two compressor or compressors and will raise its pressure as a high temperature and the high pressure R134A to the heat exchanger, where the introduction of cold water up to 20 degrees and less even can be reached up to 65 degrees, and as well as once it absorbs the heat and moves back to the clarifier or the hot water storage, okay, tanks, and between the tanks and the heat pumps there is a recirculation pump as defined before, and once it will absorb the heat, refrigerant will condensate back to a high temperature, high pressure form, then pass through the TXV to reduce its temperature and pressure, introduced back again in the evaporator as a low temperature, low pressure liquid form, and air to water heat pump can achieve in each cycle from 5 to 7 degrees, while it can reach up to 65 degrees Celsius as a maximum hot water outlet. Now moving to the water to water heat pump. Water to water heat pump absorbs the heat from water source, like water from cooling tower, like the return evaporator chill system water to be introduced here, so that it can transfer the heat to the water that can be heated on the other side. So sorry for option. The water to water air to water the water to water heat pump, and why we are calling it water to water, we bring the heat from water and transfer it to water. For the previous type that we were mentioning, air to water, we bring the heat from the air and give it to the water that needs to be heated. So simply here the difference in the refrigerant cycle that the water to water will use a shell and tube heat exchanger, okay, and as well as discussed previously, water to water here will use a chiller return water or a cooling tower water to transfer heat afterwards to the water on the other side of the unit. And by the way, the chiller return water will be cooler by 5 to 7 degrees, allowing heat pumps to improve the efficiency of the chilled system. So moving also to the complete refrigerant cycle, understand for better clearance of the informations. So here you can note the difference between both heat pumps types, which is the introduction of shell and tube evaporator heat exchanger in this refrigerant cycle, while there is no evaporator fans, there is no air source evaporator. That is the main difference. So as you already can see, the chilled water return will be introduced to the heat pump, and the refrigerant inside this evaporator will absorb the heat and will evaporate, while allowing the chilled water system to release the heat to refrigerant. It will move outside the heat pump cooler by 5 to 7 degrees and each cycle, and then the low temperature, low pressure R134A will pass to the compressor, which will turn it to high pressure, high temperature vapor to the shell and tube condenser heat exchanger, which will goes up by the water up to 70 degrees and from 5 to 7 degrees per each cycle. Then once refrigerant loses the heat to the water coming from the calorifiers with circulating pumps, it will condensate and then move through the TXV to reduce its temperature and pressure and become a low pressure, low temperature liquid form, R134A, ready for another cycle, and the system will continue operating on the same track, and it can reach 70 degrees as well as a maximum hot water production. Now, introducing the product range and how it looks like per each unit, and how it can have a variant product range for different projects. So starting by 24 kilowatt, 48, 75 kilowatt, 115, 150, 180, 224 air-to-water heat pumps per unit, while for the water-to-water, it is 70 kilowatt, 106, 140, 175, 210 to 80 kilowatt. Both units are operating with R134 air refrigerant with a future-proof low GWP and ultra-low GWP refrigerants as well. Coupling scroll compressors, US-made, used for both units, as well as we have mentioned the evaporator for the air-cooled is 5,000 salt spray tested, so it can operate next to the sea, next to the ocean, whatever you need, as well as the body is a marine grade Stuka aluminum structure for marine heavy grade operation as well. Air ambient, it can operate in ambient air of 0 to 52, and for the water to water, it can operate on a water inlet water of 12 to 35 degrees. And why it's 12? Because once it receives a 12 inlet water from the evaporator, from the return of the chill system, it have to reduce by 5 to 7 degrees. So in order to prevent freezing, that's why it's 12. And the maximum outlet water will be 65. In the water to water, it will be 70. Both the air to water and the water to water are using REAM IQ controller. Now moving to how to understand how this system works. So here you can see the hot water storage tanks or the calorifiers, the air to water heat pump, and the circulating pump between both, as well as you can see here the introduction of cold water supply and the need to install isolation valves, ground return valve, as well as a standard. Also, you can add PLVs or pressure limiting valve and electronic expansion valve for hot water production safety. And you can see here the storage tank cold water manifold, as well as the hot storage or the hot water manifold for both storage tank. And you can see that the hot loop is connected to both storage tanks or calorifiers to allow for equal storage and balanced storage of hot water inside the calorifiers. And you can see as well as this is the manifold between both tanks or calorifiers. And you can see the pump will introduce and then will release hot water as well, the flow and the return from the heat pump. And another different piping will be between the calorifiers and the building. So one between the hot water storage or calorifiers and the air to water heat pumps, and the other will be between the building network and the hot water storage calorifiers. So you can see the flow as well as the return. Moving to the water to water, we will have an extra piping because piping network. So we will have a piping network between the hot water calorifiers and the building for hot water supply and return, while the second water loop will be between the hot water calorifiers or tanks and the heat pump, so that it will receive the hot water storage. And as well as the third line and pumps that will be required will be between the chiller plant room and the heat pumps. As well as we have to mention that the heat pumps can be LAN connected as a standard features for the small capacities, so that if you would like to have master and slave configuration, as well as all the heat pumps in the commercial port can be connected to BMS, either its BACnet or its Moods bus. Now, comparing the heat pumps as a new definition to the hot water production in the market, so versus that chiller with heat recovery. Okay, so in terms of system components, heat pumps are connected to the clarifier tanks, and you will see openings here for elements or electrical heating elements as a backup. So in terms of preventive maintenance for the heat pump or for any unplanned failure, this electrical water heater might carry the load as a backup for 1 or 2 hours. While with the chiller with heat recovery, you will have the hot clarifiers or hot water storage tanks with elements also installed, but it will work as a boost. Why? Because the chiller with heat recovery can reach up to 50 or 55 by maximum. And then to reach 65 or 70, you will need to boost this heating using electrical heating elements, providing more energy cost and more energy consumption, as well as there will be a brazed heat exchanger. So on one side, you will have refrigerant inside the chiller with heat recovery, and on the other side, you will have the hot water to be heated to the clarifiers. But we will see why this hack is not good in the coming table comparison. In terms of initial cost and running and maintenance cost, commercial heat pumps are less compared to chiller with heat recovery, while for the maintenance requirement, any HVAC technician who knows the basics of the refrigerant cycle can do the maintenance. Universal spare parts, which is Copland, which is available parts, even Carroll, and as well have standard parts in the market, while for the chiller manufacturer, he is required to send his expensive specialist and expensive spare parts to solve the issue. System heater here is simple and focus only on heating, make it easier to maintain and operate, while system here will be complex and due to the integration of heating and cooling recovery in one piece, adding complexity to the installation control mechanisms besides challenging maintenance. In terms of reliability for hot water production during winter, heat pumps can produce hot water production across the whole year from with ambient from 0 to 52, while chiller with heat recovery in the winter will have lower cooling and working loads, and will decrease the performance of heat recovery. And in this case, the building owner will have a high energy consumption because the solution will depend on operating the electrical elements only. In terms of space requirements, heat pumps need dedicated space, while chiller with heat recovery might be better because it will be on the same scale. But moving forward in terms of heating capacity and seasonal limitations, so as we have mentioned, can have a higher heating capacity with COPs that can ramp up to 4 and up to 6 in water to water across the whole year independently of any cooling demand, while here the heating is secondary to cooling. So depending on the cooling demand, if it is not required like in winter, system cannot recover heat and will be inefficient, and you will depend on the operation of electrical elements, even not to boost, but to take the whole journey as electrical water heaters, because chiller with heat recovery will be off due to low cooling load in the building in the winter, as well as in terms of energy consumption and higher COP. So heat pumps will achieve lower energy consumption as heating elements, as we have mentioned, is working only in terms of emergencies, and with the higher COP of the heat pumps, while comparing here, we will have higher energy consumption and lower COP because electrical water heaters will be on demand to boost on the normal conditions, and in summer and in winter, it will have to raise the temperature of the water to higher needed, making it less efficient as the recovered heat here depend on the cooling. And for your information, here this part is installed inside the units. Once there is a cooling demand, the heat exchanger will not receive so much refrigerant for heating because cooling is required more. And once the cooling temperature is settled, the system will start to introduce heat here. So it's not stable at all to heat using chiller with heat recovery. Now moving to another part of water heating, which is the pool heating. So the units will work in the same terminologies, and this is one of the new product streams introducing in the market. Already, like the water-to-water terminology and the refrigerant cycle, it will be the same. It will be available in 5 capacities: 67, 98 kilowatt, 133, 203, 250, operated with eco-friendly R32 for environmental footprint of refrigerant, as well as will have to cool pool heating. Why? There is a dedicated solution due to chlorine. So operating heat pumps with pools, gentlemen, it should have the ability to operate with chlorine. That's why it's a different product range, because its heat exchangers will be titanium to stand with the operation of chlorine. Units will have a COP that can reach up to higher values, 4 and more of COPs, as well as low noise levels, because it's inverter technology operated for the fans and for the compressors, while it might have flexible operation modes like night operation mode, normal, and beast, which is the highest efficiency and highest capacity mode. Dual functionality to cool and heat the pool at the same time, or you might use it for heating, and then in some instance you might cool another, for example, cooling jacuzzi. Okay, but system might function like only cooling or like only heating, but having this in one solution is one of the solar options and solar standard features that REAM introduced in such a pool heating solution. Smart control using REAM IQ control, which is very easy and very basic for engineers and technicians, and as well as it can be operated with Modbus backnets, as well as with voltage-free alarms like fire or like any alarms to be integrated. Before going to the case studies, I will like to introduce this video.
Discover REAM Wave, Australian designed and made commercial pool inverter heat pumps for smart heating and even smarter savings. Since our first heat pump installation at the iconic North Sydney Olympic Pool in 1994, REAM has proven its commercial heating solutions with installations across the UAE, Southeast Asia, Pacific Islands and Africa. REAM's commitment to energy efficiency, cost savings and a reduced carbon footprint positions our heat pumps as market leaders in commercial pool heating. Wave commercial pool heat pumps are designed for high performance and reduced pool heating energy consumption by bringing together the latest inverted technology with space-saving design, precise control and low GWP technology. Wave has a range of features designed to optimize performance while keeping pool heating energy consumption down. Powerful performance needn't come with a large footprint. Wave's unique fan and coil design delivers compact efficiency, reducing space requirements without sacrificing heating power. Integrating the latest inverted technology to optimize compressor and fan speed, Wave sets new standards in efficiency and control. Central to its design, EEV3 technology provides precise control to deliver optimal performance and energy savings. With high coefficients of performance across the operating range, Wave pool heat pumps deliver high efficiency across various temperatures, making them ideally suited to the Australian environment. REAM Wave series achieves significant environmental benefits with the transition to R32 refrigerant, offering up to 1/3 lower global warming potential compared to the widely used R410A. REAM IQ, for smart heating and even smarter savings. Its brilliance is in its capacity to intelligently adjust pool heating schedules to maximize moments of low-priced electricity to significantly reduce pool heating costs. With REAM IQ, you'll be swimming in savings. Wave features smart operating modes to provide complete control. Tariff mode allows the operator to preference heating in off-peak and shoulder times. Night mode delivers whisper-quiet operation and higher COP, ideal for locations with noise restrictions and for high-efficiency operation. Time zone mode enables programmed local time zones to be implemented for scheduler, tariff and night mode functions. Wave can easily integrate with solar heating systems and adjust to optimize between demand and solar availability. BMS integration provides full system visibility for monitoring, with BACnet or Modbus cards available. Wave is designed and made in Australia and built to last. Rheem's proven systems and components deliver on reliability to help minimise maintenance costs over the life of the heat pump. Wave features marine-grade aluminium outer construction, corrosion-protected evaporator and twisted titanium heat exchanger. When reliability matters, Wave Series delivers peace of mind with a 25-year heat exchanger warranty, backed by Rheem and supported by a nationwide service and technical team. Rheem Wave, Australian-designed and made commercial pool inverter heat pumps for smart heating and even smarter savings.
Now, this is the end of the heat pump section, so we will use the remaining minutes to proceed with the VRF energy saving studies as well as heat pumps. So as you already can see, this project was a school and the consultant would like to go with the DX units for a school G+2 building with 75 classrooms, 3 labs, 3 seminar rooms, 2 sports hall, and 13 administrative rooms. The Rheem team proposed the VRF system instead of the DX, although we are one of the DX manufacturer with different solutions in the market, but Rheem introduced advanced VRF selection proposal that was using our VRF selection software and based on consultant requirements. That once the units were installed, our team tracked a lot of energy savings and lower power consumptions with different features that was added to the project, like BMS integration and central controller availability. So as per part of the load calculation shared with our team, we will be able to deliver our VRF system with 12 outdoor units and 107 indoor units. And since Rheem VRF was installed and compared to the overall electrical consumption, you can see comparing this to the DX system, there was a lot of energy saving, especially starting in the month's peak in June to October. Okay, the red line here is shown for the DX units, while the green line is showing the VRF system. That even with the higher summer loads, it delivered almost 40 to 57% less of power, which makes the solution save almost 1,050,000 kilowatt hour per year. Now, moving to the cost analysis for such a study, you can notice the difference between the red ones for the DX and the green ones for the VRF, and how the major saving is happening, as well as the VRF system for this school achieved almost annual energy saving of 70%. And you can notice here, starting from June to October, the percentage of energy reduction and cost was up to from 56 to 133, especially in June. Now, moving with some case studies for heat pumps. So this is to show the energy consumption difference to heat 10,000 liters using central electrical water heater, which will consume 372 kilowatt per hour, while you will have with the air to water and the water to water to heat using only here 99.5 kilowatt, 156 using 65, sorry, using the central water heater pumps, allowing for 73 and 55 lower energy consumption. Comparing both solutions, so we have achieved 73% less for air to water and 55 for water to water heat pumps. Product life cycle for the electrical will goes up to 5 to 7 years, while it's 10 to 15 years for both commercial heat pumps. ROI will be 3 to 5 years for air to water, 4 to 5 years for water to water, while for the operation and maintenance cost, air to water and water to water will be lower than the central electrical solutions. While for the gas boilers and the air to water heat pump, you already can see that the efficiency will be 90 to 95 maximum for the gas boiler, while it can goes up to 4,000 to 5,000 percentage more efficient for the air to water due to the higher COP. For the initial cost, almost both solutions are the same. For special design considerations for buildings, you have a headache of how you will store gas and how you will make chimneys looks good for better appearance of the building. While for the heat pumps, you have the outdoor installation that it should be installed outdoor. And as well as for the maintenance cost, it's higher to maintain the boiler with chimneys, with makeup waters, all the things, as well as for a yearly checking. While for air to water heat pumps, you will only to do some preventive maintenance yearly and some quick check that will take 1 to 2 hours. So that allowing for a lower maintenance cost compared to gas boilers. And allow me to end the training with our video to introduce our REAM Innovation Learning Center virtual tour in Riyadh. If you are interested to visit REAM and IC and have complete training, you can scan this barcode and we will contact you after the current situation in the region will come to a calm point. We will be happy to accommodate your visit after that. We provide a complete life units for VRF package units, DX, as well as hybrid heat pumps and water heaters in our ILC, as we have a complete life station area for the users to see how the solution is connected and how it's already operated on site. This brings us to our last part of the session, which is the Q&A. And thank you for your attendance today. And I hope this session presented by Reem provides you all the thoughts and how VRF and heat pump system are the future to achieve green buildings HVAC. Thank you for your attendance, and please let us know if there is any questions. Please post it in the chat. The available protocols for software integrations for heat pumps, the commercial heat pumps, it can be connected with BACnet and Modbus. So I hope this has answered your question. Depending, the heat pump is, I think my colleague Stan already answered. We will have an engineer to check with the factory for this reliability requirements. Although our units are ready to operate with power generators, but it should be stable, and there should be separate isolations and voltage stability requirements to guarantee that there will be no failure for the outdoor. So we will get back to you. And I mean outdoor failure, because the PCB are very sensitive to any fluctuations in the incoming electricity. So I hope we have covered all the questions in the training. Thanks for your attendance today, and hope the session was fruitful for everyone. Thanks, Engineer Abdulrahman from SSE side. So hope you have a nice evening. Assalamu alaikum, everyone, and enjoy Eid blessings in the coming days. Assalamu alaikum.